if we have two powers with the same base, for instance, say we have x to the third times x to the fifth, your answer is simply going to be add the powers. So my answer is going to be x to the eighth. You just add the powers. 3 plus 5 is 8. Here, if you have a power to another power, like two powers, for instance, that would be like, say, x to the third to the fourth. If you have a power to a power, what you're going to do is you're going to multiply. So it's going to be x to the 12th. If you have a power over a power, what you're going to do is subtract the powers. That would be an example of, say, x to the 7th over x to the 3rd. You're going to take 7 minus 3 and get x to the 4th. Anything to the 0 is 1. That, for instance, you could have, just x to the 0 would be 1. You could also have like 3 to the 0 is 1. Anything to the 0 is 1. Anytime you have a negative power, it drops to the bottom, meaning, say you have x to the negative 9th, that would be 1 over x to the 9th. Basically, you should never have an answer with a negative power. You always want to change it. For this one, if the negative power is on the bottom, it goes to the top. So if you have 1 over x to the negative 2nd, that we don't want the negative power on the bottom, so it jumps to the top, leaving you x squared. Now, could I put x squared over 1? Yeah, but why? That's x squared. If you have two things multiplied to one single power, that power basically distributes both pieces. For instance, say we have 3x to the 4th squared. That's going to be 3 squared times x to the 4th squared, which you could actually reduce. See, the squared went to both pieces. 3 squared is 9. And then here you multiply the power, so it's x to the 8th. And then this property is exactly the same as this, except there's a division. For instance, say you have 3 over x. If you're going to take that to the second power, it's going to be 3 squared over x squared, which is, in this situation, 9 over x squared.